Okay, now we're going to talk about working in a nuclear power plant. Now, while I'm a nerd, I'm also a huge Simpsons tragic, which is a bit of an issue when the Simpsons have portrayed nuclear so poorly for 20 plus seasons. So it's actually great that we've got Prasad Balla here to talk to us today. He's a qualified nuclear engineer and a licensed nuclear reactor operator. Sai spent over a decade as a nuclear power plant operator with the Department of Atomic Energy in India, and then commissioned and operated UAE's Baccarat nuclear power plant. He's currently a graduate student at MIT in nuclear engineering and the Sloan Business School. So, Sai, dispel all my rumours about nuclear power plant operation.
Good afternoon, everyone. So, thank you, Australian Nuclear Association, for giving me an opportunity to come to Australia and share my experiences of working in like different nuclear sector in India and in UAE. So, I have actually divided my presentation into 5 different parts. I will go through the introduction and motivation why I ended up in nuclear sector, followed up by a small description of like how a nuclear power plant works, some discussion about the design principles, how the systems are designed, a brief overview on the main control room, and finally, I will wrap up with the trainings that we undergo as a nuclear power plant operator. I aim to finish it within like 20 or 25 minutes, and I would be open to questions based on what I present here, because there is a lot of things that goes inside operating nuclear power plant, and I would be happy to address like what your thoughts about it and if there are any misconceptions that I could clear. So I come from a remote town in India. Basically, this is the Korba in Chhattisgarh. It's a tribal state, and it is rich in coal mines. And as a result, we have around 6,000 megawatt of thermal power production in my home district. So what it means is there is lot of pollution that I grew up with. And on one hand, I could see the developments that these power plants bring to the state as a whole, but I could not neglect the harmful effects that these power plants, the pollution that results from, has on the people in the surrounding area. So my sister suffered from asthma while growing up, and means I could see the challenges that we faced. The air was not clean, the water was not clean, and it was a strong motivator for me to pursue a career in clean energy sector. So in 2009, after graduating in mechanical engineering, I joined Department of Atomic Energies, Bhabha Atomic Research Center. It's a premium research institute in India. And here for 1 year, I was trained in basic to advanced nuclear topics, which laid a strong foundation for what I would be doing in the future. In 2011, after completing this complete course, I was awarded a Master of Technology in Nuclear Power Plant Engineering and Management. And in 2012, I was a certified reactor operator to run these nuclear power plants. So these are 540 megawatt each reactor. These are pressurized heavy water reactor type. And I worked in the main control room for 6 years in like actually manning it 24/7, ensuring that electricity is produced continuously in a safe and efficient manner. So I was part of the main control room where we worked on different activities that I will be mentioning in the coming slides. So in 2019, as mentioned, I moved to UAE, where I was part of the commissioning and operations team for Barakah Nuclear Power Station. So when I joined, I was in Unit 1. One of the primary tasks that I was responsible for was to take over the control from the South Korean vendors who were building the plant and transition the plant to operation state. So I worked in Unit 1, Unit 2, Unit 3, and Unit 4. And by the time in 2023, when I left for US, at that time, Unit 1, 2, and 3 were like connected to grid. And recently, Unit 4 was also connected to grid. And right now, we have, in case of UAE, 25% of electricity being supplied by these 4 nuclear power plants. In 2023, I moved to MIT, where I am currently studying system design and management, as well as I am currently doing a research project under Professor Jacopo on the topic of advanced gas reactors and the TRISO fuel, how the economics work out in favor or against these small modular reactors. So in this presentation, I will not be talking about the present work that I am doing, but it will be more focused on my experiences as an operator. So just quickly going through what is the source of nuclear energy. We have an incident neutron on a heavy atom which splits. We have like daughter products, and because of the mass difference between the products and the initial atom, the difference in energy is released as thermal energy. And brief trivia that this is a standard bundle for pressurized heavy water reactor. It weighs around 23.8 kg and is half meter in length. And this bundle is equivalent to 400 tons of coal. So I could like see the heaps of coal as well heaps of ash that is being saved because of these like moving to this like nuclear fuel. And as briefly explained by Professor Kurush, the heat energy that is generated in fission is inside this, the fuel bundles are inside the reactor pressure vessel, and this whole structure is inside a containment. I'm showing a small mimic of the reactor coolant pump, which circulates the coolant from inside the reactor, and this heat is used to boil water in a steam generator, and subsequently it is used to rotate the turbines, and it is eventually connected to the electricity grid. So in the next few slides, I will be showing like the actual these equipments such as the reactor coolant pump, the turbine generator, and the actual the circuit breakers which are used to connect this plant to the electricity grid. So here you see the pump room. This is the view inside the nuclear power plant. And in this area, you will see like several pipelines, various electricity conduits, and on the sides, these are 4 reactor coolant pumps. You can see it rather clearly over here, where these big pumps, they are used to like recirculate the coolant from inside the core and to transfer this heat to the steam generators. So once the steam is generated in those steam generators, they are transported from the reactor, inside the reactor building, to the turbine building. This is the layout of the turbine building. And here we have like 3 turbines in series. And here you have the generator, the 540 watt megawatt generator, and the exciter. And finally, once the electricity is generated, it is connected to grid using these big circuit breakers. And through this, eventually electricity is connected to the grid. So talking about briefly like how these nuclear systems are designed, I think it would be better to like just discuss briefly about the systems that we have and how we approach to that we have for operation. So nearly every system that we have is designed around keeping in mind about diversity, redundancy, physical separation, and independence. So the safety functions that are carried out in a nuclear power plant, we have to ensure that using these principles, the the resulting function that we want to accomplish can still be accomplished. So what exactly diversity is? So when I say diversity, to 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 achieve the same safety function, you have totally two different systems which are based on different principle of operation. When I say redundancy, it means like if we need a certain number of equipments, we have additional number of them. So in case if some of them becomes inoperable, we have additional of them so that the function can be we can get the function done. When I say physical separation, it means that those two equipments which carry out the safety function, they are not located at the very same function, but they are located at different locations. So in case of, say, there is a fire and one particular system becomes unavailable, because we have a physical separation between different equipments, we still have some equipments which are ready to carry out those safety functions. And independence, it means that there is no common connection between the different systems. So I would like to highlight this with the example of the shutdown system. So in this shutdown system is basically used to shut down a nuclear power plant. And for shutting down a nuclear power plant, it's basically very simple. We absorb the neutrons that are available inside the reactor. And if there is no neutron, there is no chain reaction, and the reactor is in shutdown state. So in a typical heavy water reactor, we have two shutdown systems. The one on the top is the actual the poison rods, which are held on the top using electromagnetic clutch, and they fall inside the reactor under the influence of gravity. And the second shutdown system that we have is the liquid poison, which are dissolved in these 6 tanks, and they are injected inside the reactor core based on this helium, which is in pressurized state. So when I say diversity, you can see, like, to shut down the reactor, we have 2 different systems to carry out the same function of shutting down the reactor. When I say redundancy, what it means is, suppose we need, like as per design, 5 poison tanks are enough to shut down the reactor, but we have additional poison tank which can be used in case if one of the poison tank is unable to inject the liquid poison. When I say physical separation, you can see like these particular reactivity devices are at the upper deck of the reactor, and these poison tanks, they inject at the horizontal location. For the independence, the computers or the sensors that senses the field conditions, these are powered from totally different power sources, and the computer which senses these signals are totally different and located in different rooms. So in no way a single action can incapacitate the shutdown function. So it's not that only related to the shutdown system. In fact, every safety function has built in this diversity, redundancy, and physical separation to ensure that we have highest standard of safety built in. Now moving to the area where I worked for the most of my time in a nuclear power plant. So main control room is like a nerve center from where we control the entire nuclear power plant. Here we have various monitors through which we can see what exactly is going on at different places around the plant. You can see like how much power is being produced from the reactor, how much are the steam generator level and pressure, and you can also see that how much generation is going on. Not only you can monitor, but you can also control all these equipments from main control room. You can see like different switches that are available in these panels. So means basically you are trained over a period of time, and you after receiving the certification, you could like run these equipments from here. Additionally, because many of the areas are not accessible during normal operation, so there are a lot of video cameras that are installed all around the plant, and we could monitor all these areas from a central location in the main control room to see like how the different equipments are actually running and their availability. Another thing that we carry out from main control room is are the startup functions and the shutdown functions. So usually these reactors run from breaker to breaker, which means like around 2 years, and then it is shut down for a period of around 20 days to 25 days to carry out the complete outage. So during that time, the turbines generator system that I showed you, it is completely dismantled, and in-depth inspection is carried out to ascertain the healthiness, that if the equipment is healthy for the next cycle of operations. At the top, you see like certain alarm panels. Here, you will find them in the form of like small bricks. So in this panel, you will have around 20 alarm panels. So the computers that are in the main control room, basically they senses all the parameters in the field. And in case of any deviation in the parameters, they automatically generate alarm. And most of these windows are color coded, means you can actually see the color of the lamp, and you can identify like how much critical this particular alarm is, and you can take the necessary actions accordingly. And in this, the small basket that is you have in front of it, we have the alarm response procedures located in them. So any activity that is carried out in a nuclear power plant, it's not like you can carry out using your memory. So even if you have carried out the same activity 100 times or 1,000 times, but every time you carry out a new activity, you have to refer a procedure. It has to be carried out step by step, and there is like no exception for any activity. And like we sit in the main control room, we man it 24/7, and in case we trend like some equipment is not working properly or there is some deviation, what we do is we raise deficiency request, and from the main control room, we isolate those particular equipments so that these can be released to maintenance for repair, as well as for we make sure that the equipment is safe for the maintenance using the clearance and tagging process. I think it's also the lockout and tagout process, which is standard across industry. And once the maintenance is complete, we return those equipments into service using the proper procedures. So slide, one more information for you, like in the main control room, I mentioned about redundancy and diversity. So in case of their main control room becomes unavailable because of some reason, because of say fire or any issue, because of the principle of diversity and redundancy, we have a backup control room, which from like we can transfer the control of the control room from main control room to backup control room, and it is like physically in a different place from the main control room, and we can actually shut down the reactor and make it in safe shutdown state from the backup control room as well. Slight anecdote, like while I was coming to Australia last night, I was having a discussion with the person next to me. I asked him, like, I work in a nuclear power plant, and what is your perception about the operators who work there? So what he told me, like, do you know something about Simpsons? I said, like, I have never heard about it. So he said, like, you should read about it, like what it is. So I went into internet and like read like what exactly this comic series is all about. So I think like what is depicted is like far from reality. In fact, like if you see the training program that we undergo as a reactor operator, I think you would appreciate like this is not what is being depicted in this comic series. So for training as such, we have a full-scale simulator, which is an exact replica of the main control room. So you won't feel any difference if you go into a simulator. It's exactly like a flight simulator. And while training, which lasts for around 2 years, you are trained on various scenarios. So I would say like there are like 1,000+ scenarios which as a reactor operator you can expect in a operating nuclear power plant, and you are trained on handling these scenarios to see like how you respond and whether you can actually bring back the whole operation to normal state. So you go through this rigorous process for 2 years. You establish yourself like yes, you can handle any possible transient that is possible, and also you are trained on normal operations like okay, how will you start up a reactor, how will you shut it down, or how will you carry out grid synchronization once the like turbine generator is running at the required speed. So all these routine operations and abnormal situations, we are trained on this for 2 years and 60+ system. At the end of it, there is a certification examination. So we have to secure around 70% passing marks. This is a centralized examination which is not like conducted using, not conducted by plant personnel, but a centralized headquarter-based process. And once you clear it with like more than 70% marks, then you have an interview with the plant senior management as well as nuclear regulators. And once they are like satisfied that you can actually work in a nuclear power plant safely, then you get a license to operate. And it doesn't end here. In fact, once you have a license, you go through the periodic requalification. Every year there are there are some of the tasks that you have to complete to demonstrate that yes, you still have that competency to sit in the main control room, as well as every 3 years you repeat this whole process. And the training, I would say, is like a special emphasis is laid on training throughout the process. We have like some state-of-art facilities that we have like actual hands-on experience. And once we are inducted into training school, what they say is like forget about your branch, what you studied in your undergraduate. Now you are a nuclear engineer, and you are expected to be knowledgeable about all like mechanical, electrical, C&I, as well as radiation physics. So to sum it all up, what I would like to say is like we have different type of reactors around the world, around 430, as Professor Kurush today mentioned. And each of them have evolved over a period of time. They have their own unique design. And there is a reason that they are successful in their own regards. So as operators, what we go through is we should understand the design of how these particular equipments are designed for. And while operation, we have to, I would say, like respect the design of these nuclear power plants and run them as per these design specifications. And during this whole process, I think like training is plays a very crucial role in ensuring that the operators, I have talked to the operators when I was in UAE. We could speak to different operators from all over the world, and like everyone all around the world, they go through the same rigor of actually getting trained, getting certified, and actual operating a nuclear power plant. And I think this plays a major role in ensuring the safe operation of these reactors. So finally, like because it's a big topic, I only could share like some aspects of it, and I would be like open to any questions even after the presentation. And I have my email ID listed here. If someone wants to reach out to me later, I would be happy to address any concerns. Thank you.